Hi, today we're going to be talking about a research titled BactiFind, a novel CNN-based framework to classify bacterial species. This research discusses the challenges, traditional bacterial species identification methods in diagnosing different diseases and proposes an innovative convolutional neural network, CNN-based framework. And this is titled to be BactiFind. In this research, we'll be identifying 33 different bacterial species and we'll be generating reports for the physicians. Essentially, that's what the idea of it is going to be. BactiFind has been able to show outstanding performance with 96.42% accuracy, 97.13% precision, 97.25% recall, and 3.58% error rate. This very well optimized network architecture, an innovative bypass layer, and effective image augmentation method have facilitated this performance, which has been further validated using state-of-the-art CNN evaluation methods. And we'll look down here, we can see the objectives, which we already discussed. We showed the 96.42% accuracy, and we actually will compare these accuracies over here in a second. Basically, the application analysis of image augmentation bacterial species using convolutional neural networks, and discovering optimized CNN architecture to classify bacterial species, and identifying limitations of BactiFind framework as a ground for future research. And right here we can see our framework overview, which is going to be essentially take your images with a microscope, then you store the images, upload them through the API, or you can do it vice versa, and basically you will be taking your images, you'll be resizing them, and then using feature enhancement methods, which were discussed over here. And once you do that, you will basically store them in the directory of your choice, and then you will basically run them through the convolutional neural network, and then you will get classification and reporting. And from this, we can see here, just like a different method, for example, we see before and after applying the histogram equalizer, we can see this feature enhancement method and how that worked. And this is the sample of the DBUS data set, which contains 33 different bacterial species. And we can see the actual model architecture, which has input, convolution, pooling, different convolutions, pooling, etc. And you can see it goes through, and continues to this fully connected layer, and then softmax layer, and then the classification layer. From there, you can see that we get our results of basically greater accuracy than any of the other research methods that are available that have been applied to this very popular data set. And we also have a much lower parameter rate compared to the other ones for our level of accuracy. Basically, this just shows the importance and the usefulness of using deep learning techniques on bacterial species classification and the potential for future research. If you have any questions, let me know. Thanks a lot, guys. Thank you.